In this lesson, we will be learning how to solve logarithmic equations. We will use our properties of logs in order to solve these equations. First of all, we have a goal. Our goal is to get the equation in this form and then rewrite it by getting rid of the log in what we would call exponential form. So how are we going to achieve our goal? Well, first of all, we're going to combine our logs using those properties from the last lesson. Then we're going to get rid of the log by rewriting it in what we call exponential form. Then we're going to solve for our variable. Then we need to check our answer back into the original equation. You can only take the log of numbers that are greater than 0, because if you go back to the graph of the logarithmic function, the domain is x has to be greater than 0. So we're going to look at these equations, we're going to solve them. Have your calculator out because we need a decimal solution, but we also need an exact answer. So let's look at problem number 1. Looks innocent enough. So if I say combine the logs using log properties, there's really nothing to combine here. So how am I going to do step 2? How am I going to rewrite that equation in exponential form to get rid of the log? Well, you can look at it a bunch of different ways, but we're going to probably create a new verb in that we're going to e both sides of this equation, because we're going to use that inverse property that if we have e raised to the natural log of some number a, remember that just cancels out and you would get a. So we're going to rewrite this property, we're going to rewrite this equation as e raised to the natural log of x plus 5 equals e to the 4th power. So that's what I mean, we're going to e both sides. What happens? Well, what happens on the left, because of this inverse property, we now say that this is just x plus 5 equals e to the 4th. So I got rid of the logarithm by doing that. Now I just need to solve for x. So x is e to the 4th minus 5. So this is my exact answer. Now I need a calculator answer. So I want e to the 4th. The e button is above your natural log button. E raised to the 4th power. Close that parenthesis on this particular type of calculator. Minus 5. Enter. So that's 49.598 to 3 decimal places. So this would be our decimal approximation. Now let's look at number 2. Again, we don't have any logs to combine, but we need to isolate that log so we can e both sides or get rid of the log. So I'm going to subtract 3 and get 4. And then I'm going to do the same thing I did on problem number 1. Say e raised to the natural log of the square root of x minus 4 equals e to the 4th power. Just so happens it's the 4th power again. Now I have the square root of x minus 4 equals e to the 4th power. How am I going to solve for x? Go back to algebra. What gets rid of a square root is squaring both sides. So we have x minus 4 equals e. What do you do with those exponents? Power to a power, you multiply them. And then we get x by itself by adding 4. So again, this is my exact answer. Now I need a decimal approximation. So I need e raised to the 8th power plus 4. And it is approximately 2,984.958. So again, we have a decimal approximation and an exact answer. Could you check it? We were supposed to do step 4, check our answer back into the original equation, and I didn't do that. So let's go ahead and do that right now. On here, if I put that in here, am I taking the log of something greater than 0? Well, yes, I am. 49 plus 5, that's definitely something greater than 0. What about over here? If I put that number in for x, so 2,984 minus 4, is that positive that I can take the square root of? Yes. and then I would take the log of that number, which is also positive. So that checks. Let's look at some more complicated examples. Finally, on problem number 3, we have two logarithms that we need to combine. So we're going to look at that property. Remember, the log of something plus the log of something. We can multiply those together as long as we have the same base. So this is going to be log base 6 of x plus 4 times x plus 3 equals to 1. Let's go ahead and multiply that out. Instead of e'ing both sides, I'm going to raise each side to where the base is 6, because again it's that same property. If I have 6 raised to the log base 6 of something, they cancel each out because of those inverse properties. So I have 6 raised to log base 6 of x squared plus 7x plus 12 equals 6 to the first power. So that tells me x squared plus 7x plus 12 equals to 6. Now what am I going to do? Well, I have a quadratic, so I'm going to put it in standard form by subtracting 6. Then I believe I can factor to solve that. And solving for x, I get negative 6 and negative 1. Now, don't cross them both out. Remember, we have to take the log of something positive. So if I check negative 1 back here and here, if I plug negative 1 in for x, negative 1 plus 4 is still positive 3. So that's okay. On this one, if I stick negative 1 here, plus 3, I get positive 2. So that's okay. So this answer is acceptable. What about negative 6? If I put negative 6 plus 4, that's going to be negative 2. That is not acceptable. So we don't want to erase it. Just put a line through it. That's called an extraneous solution. X equals to negative 1 is our only true solution. Next problem. Well, we need to combine those logs. They're both on side, and we don't have a coefficient of 1. But doesn't that look odd? Isn't this that same inverse property that we've been using? So I think we can get rid of the log on this one by knowing that the natural log of e to the third power is just 3. So I can combine 3 minus 1 and make it 2. I've got to get this by itself. So let's divide by 4. So 2 over 4 is 1/2. And now I'm going to e both sides. Now, because of the inverse property, I have x minus 1 equals e to the half power, solving for x by adding 1. So that is my exact answer. Let's go to the calculator and get a decimal approximation. So I have e raised to the 1 divided by 2 power, close that parentheses, add 1, and I get 2.649, and that's my decimal approximation. Checking our answer. Okay, we have a little bit bigger than 2. If I put it back in there for x, subtract 1, then I'm taking the natural log of something positive. So that does check. We can keep that answer. This last problem not only will test your algebra skills, but also your calculator skills. So let's just go through the steps. We have 3 logarithms here that we need to combine. So we'll take the first 2, and because that's a plus, we can multiply. Let's keep combining. Because that's a minus, we then can divide. Now I need to get rid of the logarithm, so I can e both sides, and I'm just going to be a little bit lazy and write it like that. So over here that goes away, and I have x squared minus 3x over x plus 2 equals e squared. Now what? I need to solve for x. I have fractions, so let's go ahead and cross multiply to get rid of those fractions. And now I see I have an x squared, so that's quadratic, so I need to probably set that equal to 0. That just doesn't look like a typical quadratic equation. It would really be nice if it was in the form of ax squared plus bx plus c equals to 0, so I could use the quadratic formula to solve for x. So maybe I could rewrite it as x squared, and let's go ahead and factor out an x out of these two, and that would leave me negative 3 minus e squared minus 2e squared equals to 0. There's an understood 1 there. So a is 1, b is negative 3 minus e squared, and c is negative 2e squared. Rather ugly. Alright, so quadratic formula. I need the opposite of b. So if I take the opposite of that, they're going to be both becomes plus, then plus or minus the square root of negative 3 minus e squared squared minus 4ac, all divided by 2 times 1. This is where test your calculator skills. And you're going to have to do it twice. You need to add that square root, subtract that square root. So get your calculator out, and let me give you some tips. You might want to push that in and then square it and say enter or equals, and you might write down that decimal. Then here, that's going to become a positive because you have a negative and a negative. Get all that. Then take the square root. Just do it a little bit at a time. You might want to pause the video, punch things into your calculator, and then see if you get the same numbers I do. You should have gotten two answers. One was about 11.65 and the other should have been about negative 1.27. If you're off a little bit on that decimal place, that's okay. It just kind of depends on how you round it. Still not done, because now we have to check our answer back into the original problem. So if I take 11.65 and subtract 3, that's going to be positive. That's okay. Here, that's still positive. And if I add plus 2 to 11.65, that's definitely going to be okay to keep. So that's a keeper. Well, what about this one? Well, if I put a negative 1.27 in here for x, then I'm trying to take the natural log of something negative, which I cannot do. So that's an extraneous solution. So take it a step at a time with your calculator. If you need help, we'll go over in class.